So my name is Tariq Islam. I'm a solution architect with Red Hat. I've been with Red Hat for a couple of years. My background is in app dev. I did a bunch of stuff for the intelligence community. My last name is Islam, so that was very interesting at the time. After that, I went into a little bit of consulting, and then I worked for Oracle as a specialist for them. And I got a lot of good experience, and a lot of that is what lent itself to this talk here. And then I found myself at Red Hat after the fact, and now I specialize in all things basically JBoss and containers, Kubernetes, and OpenShift. So that's why we have this marriage of data management and microservices. So that's what we're going to talk about today. So just to level set a few terms. Number one, master data management. What do we mean by that? And I think that's something that we all pretty much agree on, is you have a group that physically owns the data, right? When we talk about data ownership, and that's going to be an important topic that we go through today. What ownership really means, and the impact that has in a microservices architecture, especially when we talk about things like microservices and DevSecOps or DevOps or whatever the heck you want to call it. At the end of the day, what is a microservice, right? The way I typically define a microservice is usually a service that has its own lifecycle, its own code base. In the industry, it's typically defined as having a two-pizza team, right? If you've heard of that term, two-pizza team, it's usually a team of like 6 to 8 people, and it's comprised of a diverse set of individuals with diverse backgrounds, right? Now, in the federal space, and this is DevNation Federal, I mean, that's just not going to be a reality, right? At least not probably in my lifetime, where I may go into like Department of Labor, for example. No offense to anyone that's from the Department of Labor, but I don't see two pizza teams sprawled across the Department of Labor or many federal agencies. The government's just not built for that, right? Not yet, anyway. It may move towards that, and there are organizations that are moving towards that already, but they are in the vast minority. But that is, again, from an industry perspective, what a microservice essentially is. And we know, again, DevSecOps, I'm not going to belabor this point, but really this is meant to be a culture where the different teams between development teams, security teams, and operations teams are able to come together by being kept apart, right? There's a separation of concerns on a common platform, and pick your poison on what that platform is, but that platform should provide or should enable a culture in which developers are able to be very good developers, operations teams can be very good at what they do, and security can be very good at what they do without having to infringe upon one another, without imposing things on one another, and without blocking each other, right? So there's a hard lines that are drawn, and usually those hard lines are drawn and enabled through automation, right? So a lot of axioms of DevOps is through automation, things like infrastructure as code, everything automated, CI/CD pipelines, you name it. So now that we've level set that, let's dig a little deeper into microservices. And so far in the industry, the discussion around microservices has been really about the application, right? Let's talk about monoliths. Let's break down the monolith, okay? I want to decompose my monolithic Java app into 15 different microservices and deploy them out into containers. And then I want services discovery, right? It's all about the migration as well. How do I bring my application or my services into a microservices architecture using containers on top of a container platform? And it's really been about those three teams, right? How does this impact? How does this migration into this new world of having hundreds of microservices out in production that are in aggregate, providing the same functionality that 3 monoliths used to provide? How does this impacting the development teams, ops, and security? Again, this is where DevSecOps came from. But what about the data owners, the physical data owners, DBA teams? They end up being the sad pandas of the group because really they're not even part of this whole paradigm right now, right? The folks that manage the databases, that are in charge of normalizing the data, that are in charge of patching databases, all of these different things, they're owners of the schemas, right, at the end of the day. So these are some of the things that data owners do, just a subset of things. Right? I'm not going to go through the whole list, but a lot of these probably look very familiar to all of you, right? Now, what the impact that this has on development teams, especially, as well as for operations as well, but mainly for development teams, is the two are still coupled together. My application, whether it's a monolith or whether it's 15 different microservices that I've decomposed my monolith into, I'm still coupled to the lifecycle of the data. Okay, anytime the schema changes, now instead of having to make a single change in my monolith, I'm now having to make a change that could percolate across all of my different microservices. This is something that the industry right now hasn't really talked about or really thought about in a lot of, in a lot of ways. So that's what we're going to try to address. So while data owners are worried about this, app dev teams are worried about this. We want to go as fast as humanly possible. We want CI/CD pipelines. We want automation. We want to get features out into production as fast as possible. We want microservices to do all of this. And we want it now. We want it yesterday, right? And we're going to adopt containers because containers are great. They're super fast. They're super lightweight. And they're super awesome, OK? Now, if I've got 20 different microservices out there, all of which in aggregate, come from my monolith. I've migrated everything over. They're all deployed in containers, and I've got 2-week sprints because I'm, practicing Agile Scrum methodologies, right? What happens every time there's a release cycle, and there has to be like some sort of schema change to the database for me to roll out my app, okay? And that schema change is going to affect 5 out of the 20 microservices that I'm deploying. And the data owners come back and say, sorry, we're doing some patching today. Or, sorry, we really don't have that kind of time right now. Their timelines, their priorities are fundamentally different, as is indicated by this static list, which is meant to be boring because boring is good, and this awesome graphic here, right? There's a dichotomy there. So there are conflicting priorities. Now, putting the conflicting priorities on a shelf for 1 second, let's talk about the data itself. Data is still hard. Okay, just because we're now moving into microservices doesn't mean that data becomes suddenly easy. Microservices don't solve this problem. Microservices solve a completely different set of problems. And what microservices also do is actually introduce a whole new level of complexity. Okay? I love microservices architectures. I love containers. I love orchestration. I love all of that. But the bottom line truth is, when I'm talking about taking my monolithic application and breaking it up, it's almost like a parent saying, hey, we're going to have more kids because we want to be more agile. Okay? It really does. I mean, it's a little counterintuitive, right? That's just, unless I can scale as a parent, which I obviously cannot. I've got 3 kids under 4, by the way. So I can relate to this. I definitely can't scale. But you have, that's the issue. That's the crux of the issue. Now, again, in the industry, as I mentioned earlier, the definition of microservice is that it should own its own data. Now, suddenly, we're going to tell the data owners, the DBA teams, that they're going to go away and all of our 2-pizza teams are going to start owning databases everywhere? Is each microservice going to be backed by a single database? And who's going to own that database? Who's going to administer that database? Who's going to patch and upgrade and maintain that database throughout its whole life cycle? Going back to that slide with that bulleted list, who is going to do all of those things for every database, for every microservice that's out there? That is not a tenable solution. That's not a tenable future. So what does it mean for the federal agencies, for the government space that may not be as movable as, say, Silicon Valley or the commercial sector, right, or the private sector? The concept of ownership must change at the end of the day, and this is what we're getting at. If the concept of ownership doesn't change, it goes back to that problem that I described earlier, where it's hurry up and wait. We're ready to release. We got to make a couple quick schema changes, just real quick. We're just upgrading the app, made some changes to the form, so the way certain data interacts with one another, but the data owners just aren't ready for this. Okay? DBA teams just aren't ready for this. So there's going to be a lot of this. A lot of this. And what that results in, actually, is a lot of shelfware. Okay? I've been on development teams. I've been in the role of release manager, and I've seen an agile methodology, work really, really well for developers. And because of the fact that the data management teams, DBA teams, are not as agile as the development teams, there was a lot of shelfware. Things just weren't being released as quickly as they should be. This conversation that we're having, by the way, even though this is really a conversation, this is me just talking to you guys. What I'm really talking about here, this is the same discussion that the industry had between development and ops. But now we're just having the same conversation between development and the data folks, right? The folks that own the data, okay? Now, I'm not proposing that the actual physical ownership change. Okay, as I mentioned, it's not tenable, it's not realistic for us to believe that for every single microservice, and let's say, I mean, for example, the customer that was on stage earlier today in the panel discussion, DHS, they're planning on rolling out around 150 to 200 microservices, right, in the coming future, okay? Are we to say that each one of those is going to have a singular database? And this is actually a conversation that they're having right now today. This is a real problem for them. Now that we've established that we're going to move to containers, that we have a container platform in OpenShift, what are we going to do about the data? That is the fundamental next question. Okay? The answer here is to not just redefine ownership, but really take ownership over your data. But I'm not saying this in terms of like a hostile takeover. I don't mean to say, hey, DBAs, you're gone. We're going to take over the databases, or we're going to just move the data out, replicate it everywhere, and manage our own databases. That's not what I'm saying. What I'm saying is take ownership over your data through interaction with that data. Ownership of data for a given application should be by virtue of the interaction with that data, not who physically owns it, not the actual stewards or the guardians of that data. At the end of the day, for any organization, federal or otherwise, applications and workloads exist to enable the data, to give meaning to the data. Okay? The data owners themselves, their simple task is to make sure that the data survives. Okay? That the data is resilient, that the data is not lost, because this is gold for any organization. This is why the organization exists, is for that data. But the app dev teams enable that data and make the mission meaningful. So it's the interactions that each application team or each application or each user has with that data that makes it owned, right? That's where the sense of ownership has to go. But how do we move that sense of ownership away from the DBA teams and that physical ownership into a more virtual sense of ownership, right? Through that interaction paradigm. The clicker's running out of battery. So we need to abstract that ownership. And what does that mean? Define your own schemas, right? As an application team X or application team Y, out of 50 application teams in an organization perhaps, I want to define my own schemas. I want to be able to say, hey, you know what? My application expects a certain schema, and this is our view of the world. I want an idyllic view of the world into the data. Okay? Or back on your terms, how do I want my users, or I as a user, to be able to access the data? Now, if I'm trying to hit data from multiple different sources, do I really want to have to secure the data across all of those sources in a consistent way and maintain it across the board like that? Or do I want to have a central place to maintain and secure access based on my roles for my users and groups that they're part of? Including the schemas in the pipeline. So if, for example, we're about to release something, going back to my previous example, and we're making a couple of changes to the schema that we're looking at, does that mean I have to go to the data owners all the way back into the data sources and say, hey, can you guys make these 3, 4, 5, 6, 18 different changes? Rather, I want to actually be able to change the schema in my own view of the world. This seems a little weird. I'm going to get into it. We're going to build out an architecture, and this is going to make sense. I want to access data as a service. This is one of those advantages of bringing things into a microservices world, especially with service discoverability. I want to maybe expose certain data that I have in my organization as a service, both to application owners as well as to other external agencies, perhaps. Right? I want to be able to expose it as an API. I want to assign metrics and monitoring to it. There may be one single monolith, as I had earlier. But more often than not, if you give application teams, especially analytic teams, the ability and the option to hit more data sources, the answer will always come back as yes. So I want to be able to hit multiple different data sources all at the same time. I'm talking about federated queries now. And I've been to organizations where people have necessarily custom built their own federated query platforms, and they've been very bad. Okay? There's always performance issues associated with them. There's always something that causes it to fall down. They end up becoming fragile. It's a custom-driven solution, and God forbid if the guy who developed it gets hit, or the girl gets hit by a bus, right? The idea here would be to connect to those data sources, and really these three lines, these three boxes here are really just those lines that I had drawn up earlier. I'm going to make real-time connections into the data sources. Then I'm going to compose my idyllic view of the world. I want to be able to say, hey, I want column X from this warehouse, or column X from this table from this warehouse. I also want to tap into the CSV file. I want to make a REST call out to this enterprise application. I want to hit a MongoDB instance, and I also want to talk to Hadoop. And I want to bring specific data points from each of these different sources and compose that into a virtual view or a set of virtual views. Basically, I'm defining my schema, right? I'm owning my schema at this point. Then I want to make that schema consumable. Consumable through what? I want to make this into a RESTful endpoint. Or I just want to have the application hit this virtual view or virtual views through JDBC, ODBC, or what have you. Okay, standard-based protocol ways to interact with the artifact. So making it consumable. At the same time, I want to secure it, right? I definitely want to secure it. I don't want to have to worry about optimization too much, right? I want some sort of optimizer already there. I want some sort of query planning going on. This is the type of thing where a lot of folks who custom build their own federated query model fall over, is the optimization piece and the query planning piece. And I want an easy way to do this, right? I don't want to hand jam XML all day, every day. Really, at the end of the day, this whole construct here, the deployable artifact, is really just, it's just metadata. It's like XML metadata under the hood. Now, I don't want to hand jam all that every single time I want to go through this process. I want a nice, designer. I want some sort of drag and drop capability. But really, at the end of the day, from a data consumer perspective, I just want to get at all of this data without actually having to go to the owners, the physical owners of that data. I want to own through interaction. Okay? I have TID up here. That's the open source project that actually enables this entire thing. The only thing that's not included in here is the data grid. But, well, we have data grid right there. But any questions so far on anything that I've covered? I think that's all I've got. Yes, and I still have got a couple minutes to spare.
I'm interested in writing that. And some of your sources,
yes.
read-only sources.
Mm-hmm.
So
how write-backs occur?
I mean,
Yeah, so
transactional speed and stuff.
Mm-hmm.
Optimization.
Yeah, so just caching in-memory database aside, if you're just going straight to the sources, this is usually dependent upon the JDBC driver that you're using. Hey, Mark. The JDBC driver, like for example, if you're using like a DB2 instance underneath here, and you want to do write-backs, you have to make sure that you use like the right XA driver, for example, right? So that's actually a bit out of the purview of this. It's more. What's that?
It's actually only federated, but it's not, writable.
No, you can do write-backs. You can do write-backs, but you have to, as long as you're connecting to the data source with a JDBC driver that allows you to do that the right way. Yeah, write-backs are there. And we've done that in a few places. Yeah. You had a question?
From an implementation perspective, TEED is your virtual database, right? And data grid is your in-memory application.
In-memory database. Yeah, we have the foremost expert on JDG right here, by the way, John Osborne. Yeah, not to call you out, but if there are actual, if you got deeper questions for that, he's your guy. But yeah, TEED is the community project. So.
How's that spelled?
I always ask that question too. So TEIID. I forget every time. Yeah. Yeah. Yes.
The use case that you had for having the virtual databases, that was for a for a read use case, and let's say you're adding a new field or a new column, and you're writing. So, I mean, in that use case, you can't avoid the change riffling back into the
I agree.
data source.
I agree. I agree with you. Yeah. So again, I never claimed that this was a panacea, right? We're talking about decoupling. We're not talking about complete freedom, right? So there are still some things that you're going to have to be able to do, right? Now with that issue there's more control that you have with the data grid here. Okay. By the way, there's a whole like people process thing going on here. Who owns this, right? I'm contending that there's a line drawn here where you have your data owners up and then your app dev owners down, right? So you can own that whole interaction that you just described, but there has to be some sort of process among the people involved to actually, before the asynchronous write back happens, that hey, make sure you make this update or this change. And we can hold on to the data. We can hold on to that change and write back when you're ready. But there's a whole process that you'd have to put in place for that. And again, this is talking more along the technology. I haven't talked about the people or the process changes that would have to occur here. There's a lot that would have to occur here. I want to put that disclaimer down. Okay. Yes.
So the previous talk here was about Kafka and stream processing.
Yeah.
Which is, I guess, trying to solve similar kind of problems. How do you see this architecture? Better, saying like.
I would see like Kafka and stream processing as like augmented to this, complementary to this. It depends on the use case. It really depends on the use case. I mean, this is supposed to be kind of a generic architecture. I mean, I've seen architectures with. You really about to ask a question? Oh yeah, please go ahead.
So a lot of people are using Kafka or also using Apache Spark
Yeah.
to do the kind of processing of those streams. You can use JBoss Data Grid to stream things into Spark or out of Spark, and also use that as a data store for Spark, like a place like Hadoop. So if you wanted to stream Kafka messages into Spark, and then that flows streams all the way into Data Grid, then you can put the virtual database view in front of that to do like traditional SQL calls or whatever else you want to do.
Yeah, John and I are working with folks that are actually doing that right now with their architecture. In the federal space, of course.
Actually, JDV, right?
Yeah, it's JBoss data virtualization. That's the downstream. It is a JBoss product.
How about transactions across different, that's spanning across different sources?
Yeah, there's a rollback that occurs if there's like a failure. So there is some intelligence in JDV to be able to detect things like that. You also get things like push down predicates for queries and things of that nature, where it's intelligent enough to know what to push down for performance gains. So, not saying that the rollback is absolute across the board for every kind of source, but for the bigger ones, yeah. Any other questions? We're about a minute over, so I got to cut it off. But I appreciate y'all coming. Thank you very much.